Introduction to Complex Numbers. We first talk about imaginary numbers. We introduce imaginary numbers so that we are able to take square roots of negative numbers. Okay. In order to do that, we define the value I equal to the square root of -1. This little lowercase I, is usually in italics, is actually not a variable, but it is a number. It is an imaginary number that represents the square root of -1. So if I represents the square root of -1, then if you square it, squaring it will just take away the radical. So I squared will be equal to -1. Having this value of I enables us to take square roots of things like the square root of -4. If we think of the -4 as a 4 times -1, then we have the square root of 4 times the square root of -1. The square root of 4 is 2. The square root of -1 is I. So we now can take the square root of a negative number. Now, let's look at these examples. Here, the square root of -100. I know I can think of that as the square root of 100 times the square root of -1. So because 100 is a perfect square, this ends up to be just 10i. Now, the square root of -96, I can still think of the -96 as 96 times -1, but the 96 is a radical that I'm going to need to break down and simplify. So let me think of the 96 and think about what perfect square factors, what perfect square numbers are factors of 96. If I divide 96 by 4, I'm going to get a 24. So I know that 4 will go into it. But if I look at that, I know that 24 also contains a perfect square. 24 is 4 times 6. So if I think of that 96 as 16 times 6, then I can break this down into the square root of 16 times the square root of 6 times that square root of -1, which is I. So the square root of 16 is 4, the square root of 6, and then the I. So the square root of -96 is 4 times the square root of 6, I. Now one thing I want you to notice about this problem is we have a negative inside and outside of the radical. These do not cancel each other out. What we have to do, though, is simplify this radical. So we're going to have to do the same sort of thing with our 32 that we did with our 96. So if I think about factors that go into 32, oops, 32, not 36. I know that 32 is 16 times 2. And 16 is the largest perfect square that would go into that. So I would have the negative on the outside. Then I would have a square root of 16 times the square root of 2 times the square root of that -1. All that gives me the -32 under the radical over the 4 on bottom. So that's going to give me a -4 times the square root of 2i over 4. And what happens here is these 4's will cancel out. So I have negative square root of 2 times I. Okay, now that we've looked at just purely imaginary numbers, we look at complex numbers. Complex numbers really have 2 terms to them. The first term is the real part. The second term is the imaginary part. It has the I in it. So complex numbers have this form a plus bi. Even these numbers we were just working with, this negative square root of 2i, is a complex number. It just happens to be that the real part is 0. So we don't write that there. Now, sometimes we have to take a number and write it in this a plus bi form. So what we want to do is take this 10 plus or minus square root of negative, I didn't get the negative in there, negative 20 over 6. And we want to write it in a plus bi form. Now, it also needs to be in a simplified form. So the first thing we need to do with this fraction is put each term over the 6. Do 10 divided by 6 plus or minus the square root of the negative 20 divided by 6. Now I know that my 10 over 6 is going to reduce. That's going to reduce to 5/3. So my real part of this number is 5/3. But now I need to work on that square root of 20. So I need to simplify that. Let me just take my square root of negative 20 over here and let me work on it. This is going to be a square root of 4 times the square root of 5 times the square root of the negative 1. So the square root of 4 will give me a 2. So I have 2 square roots of 5 times I. Now this one I can also simplify. You see the 2 on the outside of the radical and the 6 in the denominator? I can reduce both of those by a factor of 2. So I end up with 5/3 plus or minus the square root of 5 over 3 I.